Hello my friends and welcome to another episode of Inside Out Electronics, and today we're gonna tell you a little bit more in details about this simple camera slider I designed and, as you see, manufactured, and it was featured in this video when I show in my stop motion animation how this thing was 3D printed and then assembled together. And today we're gonna talk a little bit in details how this thing works, what are the features, about electronics and things like that. So as you see, this is camera slider. It has a 500mm travel time over here, 500mm rails, but because of the base is 50mm, it can only travel from this side to this side, 450mm. It is a very simple camera slider. It does not require any bearings. It uses two carbon tubes. Well, you can use steel tubes if you have. Those are 12mm carbon tubes, and this little base just slides on them, and this this side of the base is actually free. I have two designs. One design is actually wraps around this carbon tube, another one is slides freely. I'm not sure which one I like more. The only good about this one that you can easily twist and turn your camera when you need to, unscrew it. It's so much easier, right? That's my take, and decided to do it this way. But I have a 3D file when it is actually wraps around this tube as well. So this base where a camera attached is driven by this stepper motor. There is a GT2 6mm belt, two 20T pulley which actually connected to the belt. On this side doesn't have to be 22 toothed pulley, it can be just smooth, but I decided to use toothed one. It's a very simple contraption. It's all mounted on this 20mm 20 by 20mm, and in this case this is acrylic profile, but it's designed to be used with a 20 by 20 aluminum extrusions. This is the main idea. I just didn't have a piece of extrusion, but just happened to have this chunk of 60mm long aluminum acrylic extrusion, and I like to upcycle things, and it actually look here pretty good. It'll be much more schmick if it would be aluminum extrusion, 20 by 20 aluminum extrusion, but just happen don't have one. But it doesn't really matter. It actually serves the purpose. So this part is for mounting into tripod. It has standard 1/4" tripod mounting holes, 1, 2, 3. You can use any of them, and this one essentially kind of symbolizes the tripod screw. Goes inside here, and you can mount it to the tripod. Over here you have holes, so if you want this thing to be very secure on your aluminum extrusion, you can actually use T-slot screws here, M4 I think they are, and secure it to your 20 by 20 extrusion. I decided to use, on this side there is a 1/4" screw, and if I just tighten it like this, it is essentially the same side as the tripod mounting side. You can either use it one way or another. I can secure it without using the aluminum extrusion T-slot nuts. Okay, let's go to this part of the business. So over here we have limit switch, which is connected to controller, and we have a stepper motor which is connected to controller as well. Controller is designed to be removable. It also has holes on all three sides, which you can use to secure it to your 20 by 20 extrusion. But if you don't have one, in my case it just slides around. So this controller, the feature here is you can do this if you want. Alright, if you prefer to have some controls here. Unfortunately you won't be able to do, well, you still can do that, but not all the way. So that's the idea. So it's completely, you can reorient it the way you want, well, providing you have longer wires. Alright, so let's leave it in this kind of position. So controller itself, we will take a look in a moment. Let's take a look on the back first. So let's finish with all mounting parts. Over here we have this base part, which is secured by 2 screws to the main part, and there is again little mounting holes for your T-slot nuts. You can just secure this to your 20 by 20 aluminum extrusion. That's the major idea. Belt is connected to this base using simple toothed kind of slot, so you can stretch it as much as you want. It's not probably the best solution for this task, but it works. I have an idea actually to redo this a little bit and make it like in a way that it's the belt pass goes like this and this one goes, sorry, yeah, just like that. So in this case you would be able to twist and tighten it a little bit better. So this is quite important. This be nice to, it's very important to have this belt stretched as much as possible, because if it's not stretched well enough, this base is going to be jerky. So that's quite important. The movement of the base will be jerky, but right now it's more or less okay. So let's talk about controller. Let's disconnect those two guys. Limit switch right now is not secured. I was just lazy to screw it in. Okay. So controller consists of 12 volt, well technically it can be like up to 18 because there is a voltage regulator inside and there is a power switch. Alright, let's take a look inside the controller and probably take a look a little bit closer, zoomed in. So here is the how controller looks like inside. So over here we have mounted at ICBC NRF 52840. So this is Bluetooth enabled microcontroller from Nordic Semiconductor, and it's sold by Adafruit Industries. So I think it's pretty good candidate to use it for such a task, because it's very easy to work with Bluetooth with this Bluetooth module from Nordic Semiconductor. And there is I decided to use this particular one because there is a whole bunch of different examples, and even Android app you can or I quickly adapted to my needs in order to actually talk with the phone. So the main idea here that this little guy talked to the phone, and phone talked to this, sends the commands, this guy sends the reports back. So this is the major idea. So this is the heart of the operation. The execution or executor of the operation is this stepper driver controller. This is very simple stepper driver controller, and it's mounted on this sort of daughter board, which has no more than just the DuPont connectors and this controller plugged in, like one capacitor and some switches over here. Power for the stepper motor provided by those two pins. This is, in this case, it's 12 volt. I feed 12 volt. Here is the power jack. There is also 7805 a voltage regulator over here. Very simple, very crude design, a voltage regulator, and as you see, just one capacitor. I think it is 100 nanofarad. Yeah, I think it's 0.1 microfarad, if I'm not mistaken. Forgot by now. Right, there is a switch, on-off switch, and when you power this on, the microcontroller actually has LEDs which shows that it's ready to work. And also I color coded different operation. When it's moving, it's one color. When it's idling, it's or finished, it's different color. There's a little hole over here where you would be able to see. I make those bunch of holes over here in order to ventilate the stepper driver. Not sure if it's necessary. By the way, it's not important what kind of stepper driver you're using over here. I will list all compatible stepper drivers with this with the library I'm using inside this microcontroller, because I'm not sure I haven't tried any other than this one. I think It's a 49.98, but I think this library is pretty generic. It's supposed to work with every stepper driver in just regular mode without any fancy stepping and step modes and things like that. It uses 1/16 stepping at the moment. Right, I think this is all from the perspective of electronics. It's fairly simple and straightforward. The Arduino code is available on GitHub, Android app is available on GitHub, and I'm probably gonna shortly publish APK that you can sideload, or if you want you can build it yourself. So as far as electronic goes, I think this is pretty much it. Please refer to my website in order to get a little bit more information and actually details on each individual parts and where they can be purchased if you want to build this yourself. It's actually fairly straightforward. Everything is breadboard based. All those jumper wires, I think you just have to make sure this is all it's solidly connected. It's connected well. Obviously voltage regulator, socket and power switch are soldered. Alright, this is gonna be it as far as electronic goes, as I mentioned before. And footage. So I don't have any specific footage, but I did few videos in the past, and here is the one and here is another. Please take a look at those. It will give you some point of reference how this thing operates, because I test this prototype per se in those videos just to see if it's worthwhile to finishing this finishing this project. So I think this works pretty good, and but it's not designed to be used as a as the video slider. I wanted to have it designed to be used as a time-lapse slider, because hence I'm using very slow speed. This thing is capable to moving at the slow speed, this slider like for long amount of times, like for hours. But if you want to have fast movement, this thing is not capable, because I'm using the library which is not capable of producing pretty high speeds of to drive stepper drivers, stepper motors on a high speeds, unfortunately. So I have to pick another library for this stepper motor to be driven at a much higher speed. So this is the issue with the library itself. It really depends. It's actually served my purpose. If someone wants to, you know, implement something else, be my guest. Have a source code over there. It's publicly available. If you have any questions, please fire it up. Please discuss it in under this video. I will be happy to hear any feedback. If you ever try to build one yourself, I'll be more than happy to know. Please share this with me. If you want to know more, yeah, I'm happy to help. Yep. So please refer to the website to get more information and all technical details. Bill of material is there as well, and any information you require to actually build one yourself. And all parts are listed as well. So thank you guys for watching, and thank you for supporting. Some people were really supportive in this project. Thank you very much. And if you like such video and such projects, please support me, like and subscribe, share, and see you next time.